Welcome everybody today to Novatec All In. Every time we do one of these podcasts, we're going to have a special guest focusing on conveying, blending, and drying. We had a customer in recently, and that customer said this was the best day that they've ever had of getting information from the supplier. So this is our way of trying to make that happen virally for all of you out there.
Cheers.
Cheers.
Drying, no black magic. There's a science to it.
Everybody tells me how dry they're getting the outside of my pellet. Nobody can tell me how dry they're getting the inside.
They're using more than double the amount of compressed air to do the same job.
The same plant with the same material will have a different set of processing parameters in July as opposed to January.
I'd like to welcome everybody to Novatec All In. And we're here today with, you got 100 years of experience, maybe over 100 years with our special guest today. But first of all, I'm Conrad Bessemer, president of Novatec, been in this industry for 50 years now. And so I get half of the 100 at least, okay? And Tim Noggle, of course, is one of our regular guests as well. Tim, how many years in?
So well over 30.
Well over 30. Greg Washburn?
32.
32. Well, okay. So
I think you and I actually came in the industry at the same time, the same year. We just didn't come here the same year.
Yeah. So you can sort of tell by hair colors, I guess. All right.
Greg's just maintaining better than the rest of us.
Okay. And of course, today we have a special guest. I got to say this story because I go to these trade shows and this guest and I, we're walking down the aisles together. And, you know, sometimes it goes to my head that, gee, I might be president of the company. But also these people rush from the aisles to greet Dr. Dryer, right? They ignore me completely and go to Dr. Dryer because I made him an all-star. Okay.
Thank you.
So, Mark Haynie, welcome to Novatec All In.
Thank you.
And Mark, you've been in this industry for how long?
I've been doing drying for about 45 years, a little bit more.
45 years, and Novatec, how long?
26.
Right, and the predecessor to Novatec was that
A company called Kemp, which was also a dryer company. We did more high pressure dryers compared to lower pressure systems.
right. And I think as I recall, you started out of school or something as a intern or working first for WR Grace.
I worked for WR Grace as a co-op.
Right.
And
But you actually were
and I learned how to make desiccants.
Yeah.
And somehow that led into dryer systems.
And I can guarantee you, none of us have ever made desiccant. So you're way ahead. And Mark, in my 20 years here at Novatec, Mark knows more about the ins and outs of drying and polymer chemistry than anybody else I've found in this industry.
Certainly the science of drying.
The science of drying is and truly there is
Absolutely.
Science. So that's why Mark's here today, and we're going to talk about drying, but in particular we're going to talk about the Nova Dryer, which is a product that Novatec has had for some period of time, but is really timeless and obviously you were one of the inventors of it, and I want to thank you for that. And we'll talk about why it works, how it works, and why it is still a groundbreaking design. Tim, you want to add anything to that?
Well, it's been a great product. Obviously, we have thousands of them out in the market, and customers have been very vocal about their affection for the technology and for the dryer. But it was time for a refresh, to update some things and make it a little more applicable to some of the applications in today's market. And so I think that's the key of what we want to talk about today is some of those things that we've kept the good and updated some of the things that may have been getting a little long in the tooth.
And I think even though we talk about things getting long in the tooth, so to speak, the timeless part is just the savings that it provides in using less compressed air, and it's very novel dual flow setup in terms of air distribution, which we'll talk about in depth today.
So
Greg, you've been here with Mark most of that time, and
Yeah, the whole time. And preceding.
so why don't you get right into it, and let's talk a little bit about the compressed air dryer.
I remember when the first design on it. That was we actually the very first we started in late '99, and took it to NPE 2000 and the original iteration of it. So even from the get-go, from a design and engineering perspective, it's always been what I consider to be simple elegance, right? Because of the fact that as an operations person, I can appreciate the fact that one, it's not horribly complex to build, which is great from our perspective, but the technology behind it really, I guess, provides a level that most people don't appreciate. So I think that's where Mark's background really came into play, because some of the drying perspective of it was really based upon things that you had used in a prior life, right?
Yep. So when I was working with another small company called Monsanto, they developed a polymer that allowed different gases to pass through at different rates. So we took that and we had a version of it where we made first it actually came up with a hydrogen unit to separate hydrogen out of feed streams in chemical plants. Then it went to a nitrogen unit because, and we'll talk about things a little bit more in detail, but there's a variable rate that different gases pass through the polymer, and nitrogen's a very slow gas, water and hydrogen, and that's the reason why it's used in those cases. So, I was with a company called Kemp, and the company built the units for Monsanto. And so I was involved with the early production of the membrane prior to it going into.
Talk to me a little bit about the membrane. What does this membrane do, and how does it? That's sort of the heart of the desiccation process, right?
Yeah. So if you want to just look at the really simple things, is if you ever go to an airport, the tires in the airplanes are full of nitrogen and not air. They don't put air in it like you would on your car. They put nitrogen in it because polymers let oxygen pass through. So if they didn't put nitrogen in the tires, the oxygen would permeate through the rubber, and every time the plane came down, they would have to have its tires rebuilt. So that's one of the fact that the polymer, whether it's a rubber or polysulfone or a nylon, and there's different versions of this, they allow gases to pass through at different rates. So things like argon, the air we're breathing is 78% nitrogen, 21% oxygen, and about 1% argon is the primary, a little CO2 and things like that. But with 21% oxygen, and oxygen's permeates very easily through the fiber, it makes sense that your tires on your car change over the course of time, that the airplane would have to have its tires refilled a lot more often. But then you taking that property and using it and making a hollow fiber where the gases pass under pressure in the inside of the fiber.
So what gases are passing through?
So oxygen, CO2, and water vapor all pass through the fiber relatively quickly. The one we're doing with the Nova dryer, we're using primarily the CO2 and the water pass through the fiber. Oxygen's a bit slower.
So you're taking the compressed air.
Yes.
From
just a compressor in your plant.
Right.
We normally would see a lubricated compressor.
And the whole purpose of that membrane is to do what?
To take, and it's the feedstock. So we're trying to get dry air too, and that's what's used in -40 air, -60 air is used, dry plastics in most cases. And if we could take and just remove the water from it, then we have a good feedstock for a dryer system.
So somehow this compressed air goes in through these various tubes and filaments and fibers.
There's maybe 1,000 individual
of them.
fibers in there.
And then the water is expelled through that membrane.
Right. The water, there's a small, and it's kind of self-purging, because the water and a little of the other gases, a small amount of the other gases pass through and flush any of the water that's released from the membrane, and they flush it, and they kind of automatically purge the membrane and remove the water. Remove the water.
So the design porosity way. Yeah, you can design fibers with different porosities to separate different things.
Porosities to different molecules.
Gotcha.
So,
Right.
So
these are specific to water.
Sensitize the surface to allow different gases to pass through at different rates.
Okay. So these are specific to water. It's designed to
And
separate
keep
that out.
and try to keep almost everything else in the stream that leaves as a product for the unit.
Right. So what is most of that air still going onward to the process then?
About 85 or 90% of the compressed air that comes into the membrane leaves as a product stream.
So very little of it is used in the desiccating process.
Consumed.
Okay.
Right.
Okay. So, but I guess like most things in life, there are membranes and there are membranes. Because I hear, lots of people are using membranes, but they seem to have all different qualities to them, and I know all different price points, and some of them are really large and some of them are really smaller. And so why is this membrane that's being used?
Well, there's membranes used in the medical industry for dialysis
talk
and
about
things like that.
Let's talk about other membranes in this industry that might be used on other types of dryers.
So the size of the fiber and the polymer of the fiber makes a lot of difference. And also the fragility of the fibers, because there's some fibers out there that are very fragile. They have a very finite life. We're able, on this product, to give it a lifetime warranty, truthfully, because they don't fail. They never fail.
How does that happen? Because here, there's a lifetime warranty on that membrane on the Nova dryer. But yet I know there's another dryer manufacturer out there, but the replacement membranes is the number one thing that gets replaced in that dryer. So what's the difference in those membranes?
A lot has to do with, you're going to put 70 to 100 psi pressure on the inside of this membrane and allow these gases to pass through. If that membrane is not very flexible, if it over the course of time it gets more brittle, and some polymers, you look at your trash can outside, if the trash men smash it around enough, you end up getting cracked up. So you need a polymer that's very versatile and has a long life without degrading. And we have a membrane that we've selected that's very much has an extremely long life. We have membranes from that originally when Greg talked about it from 1999 that are still out there doing the same job as they did when we put them out there in 1999.
And the crazy part about that, just a quick side story, is it was just in the last probably 2 months that Larry Yingling, who's been building these for probably that entire 20 years, he had a membrane that was dated from, 2003 or 2004. He's like, yeah, I put it on test, it fired right up, minus 65, like within 10 seconds, right? So the fact that the durability, I think, is a crucial part of that, because, two things. One, we've seen this, the other membranes that you're talking about. The other thing, besides how well the material is how they pack them in there, because they are not well packed as the other part of that, right?
Exactly.
So,
because what you want to do is you want to keep the size of that component as small as possible.
Right.
And there are membranes out there with the membranes are just
they're flopping inside.
And they just move around.
Yeah.
So all that movement will cause wear and cause breakdown, right?
Any friction. So
interesting.
These are made and they're potted in such a way that they stay stationary in there all the time, and there's no movement of the fibers in there.
So that's basically a lifetime. So I mean, the comparative in the dryer market is changing desiccant beads, for example, where people have to change it because the beads break down. But this thing truly never has to be replaced.
Never has to be replaced. And one of the beauties of it is there are polymers out there that it off-gas things. I mean, if you look at like cellulose acetate or a nylon, a PET, they give off gases. And those gases have the tendency of condensing at some point in time when they hit a cold surface and could contaminate something. But we only put the air through the membrane one time. It's a once through. Now, we'll get into more a little bit later about the fact that we recoup some of this air, a lot of this air, the majority of the air, and use it again.
But it doesn't go back through the membrane.
But it doesn't go back through the membrane. So we don't contaminate that membrane over time, even with the plasticizers, the acetaldehyde, the oligomers, the things that come off of plastics.
Right. Which is the enemy of
which is the enemy of desiccants.
Right.
Whether it's a wheel or a beaded type desiccant, it can be contaminated by the recirculation of the off gases back into the desiccant again. That never occurs in this unit. Right. And it has no moving parts. I mean,
so I know, in many companies, obviously, from a manufacturing point of view, they depend on selling spare parts, but this has one of the lowest percentage of spare parts.
Oh my gosh! Yeah.
In our entire product line portfolio, which is great for customers, obviously. And as I recall, the filters really are the main thing you have to worry about.
There's the two primary filters. There's a 1 micron and a 0.01 micron filter. So everything that's in the compressed air is removed prior to going into the membrane. And then there's also another filter in the recirculation loop. If you change those three filters once a year, you can forget anything else about the dryer other than running the plastic.
So those filters are there to do what exactly?
So when you come from compressed air, you're going to have some oils. You're going to have some rust off the piping system, pipe scale, and you want to get those out. You don't want to put those into the membrane. And we do a great the two filters we use do a great job of filtration. Then we have another filter that's primarily just a particulate filter on the recirculation loop to make sure that anything that was picked up from us in the
process,
in the piping system, we remove. So if you keep it clean, keep the system clean, and we do with the filtration, you got a life that's amazing.
Okay.
Well, and we should be candid and clear, because we don't get these membranes from the same guy who sold Jack his beanstalk beans. They're not magic, so there are things that can hurt them.
Yep.
And they're primarily, though, molecular breakdown type of things, right? They're not contaminants, so to speak.
Well, if you get oil into it, and because you didn't have good filtration, you can coat the membrane. Now it will come off, but you can coat the membrane.
Sure, but so taking care of those filters is
the only other thing is that ozone is a particular contaminant that it's present in the air, but if you have most all compressors now, 90% plus compressors out there now are what they call lubricated screw type compressors.
Sure. Right.
And what happens in a lubricated screw compressor is any ozone that's in the air attacks the oil in the compressor.
Sure.
And it's removed. So there's no ozone that would come through a compressor system that would get into it. And there is one type of compressor. It's a non-lubricated compressor. They make some non-lubricated screws, but most compressors that are non-lubricated are centrifugals. They're many stage fans.
Yep.
And each stage raises the pressure a little bit, but they don't have filtration in them. And then there's a catalyst that's in there that takes 2 ozone molecules and makes 3 oxygen molecules. So once again, just like the membrane, it's a catalyst. so it's not consumed in the reaction.
Sure.
So even if you needed the rare cases that you need something like that, it's a forever catalyst. So it's a
You know, there's
forever
one
membrane with a
customer-
forever catalyst.
We had one customer where the plant was literally at the end of a runway.
Airport runway, right?
And they were
yeah.
using a centrifugal compressor, and
Right.
So there's nothing filtering out the ozone created by the jet engines.
The jet engines
Yeah.
create ozone. And
To make it worse, that plant's also right next to a major highway, which is getting all the exhaust gases off the highway. So it was the
and they were bringing
most
and they-
difficult
and the
of all
fil- and
circumstances.
the intake of the compressors was from outside.
From outside,
was
right,
from
exactly.
outside of the building to.
So once that was identified, though, there is a solution for
Yeah,
that.
and
You
it's
know,
a
there's
very simple
filtration
solution.
you put in place. But yeah, and the other thing I think that we've seen in very rare occasions is people who have welding operations inside their plants, and they may be somewhere near the compressors. Welding will generate ozone
And what happens
contaminate that as well.
in the lubricated type compressors
Mhm.
is that the ozone attacks and destroys, thins out the oil.
Sure.
And when you come in and they do their service on your compressor, they change the oil in your compressor,
Cleans it out. Yep.
and it's another reservoir for all the ozone that might be in the tiny amount. It's parts per billion
Sure.
to start with, so
Sure.
you're not talking about a whole
So it's
lot.
not a very common problem, but we have seen it in rare occasions and are familiar with it. I think most people probably could see this if they were aware of it, because ozone actually also attacks seals in everything.
Right.
And most customers we see that have had this kind of reaction, after they realize what it is, they say, "Well, that makes sense. We've been replacing seals and cylinders and all kinds of stuff. Now so I think it's just a recognition issue.
we don't run into it very often.
No,
It-
not at all.
It has come up. And
Yeah.
Obviously, we work with our customers, make sure they get over that problem.
Sure.
But 98% of the time,
98% of the time, you don't
exactly.
worry because
Yep.
they have a lubricated screw compressor, and it's a very efficient compressor, easy to service, easy to change the air end if something even happened to the compressor.
Yep.
So the industry has kind of moved in that direction.
Exactly. Yep.
so, but it's like now is a great time to take a little break. And our tradition here is that we taste some beer.
Sounds good.
Tim would like to break down and try some bourbon sometime, but no, I don't think that's today. But we're going to taste some beer. I'm going to turn that over to Tim for a little.
Yep.
bit.
Let's take a break for a minute, and then we'll come back
and we
we'll-
please want
do
you
that.
folks to join us in that, and we'll talk about the beer a little bit and parts of the country where they're from and so forth. So
Okay, let's take 5, and we'll do that.
okay, and welcome back, and Tim, you're on.
So we take turns providing the beer samples, and this time I had the opportunity to do that. And full disclosure, I am not a craft beer expert like my friend over here. Greg probably knows much more about craft beer than I do, but
nor are you a shareholder. Any of
that's exactly true. Yes. So I had to go to my local beer meister, and he recommended not a beer but a brewery, Beer Tree Brewery, which is in Binghamton, New York, and the greater Binghamton area. So shout out to our rep partner up there, Jeff Campbell in Tech Sales. Jeff takes care of the Binghamton area. So he recommended 2 things. One is a hazy IPA, New England style, called Polar Winds. And then I chose this one because it is within the theme of today's discussion, Dry Irish Goodbye, which is an Irish stout. So I thought we'd try a little bit of each and see what we all think. So I'll pour a sample of this one first.
this is a stout. Right?
This is the stout,
Oh yeah,
a little creamy.
looks like a stout.
In theory, you should always start light to dark.
Well, See, that's why I said I'm not nearly as
Pass it down. Pass it.
There you go. Thank you.
Thank you.
Yeah, because I guess this will coat the tongue a little bit, right? As opposed to
Everything will, if you go progressively darker, then
And you have the water to cleanse between.
yeah, that's right. That's the balance. We're okay.
So again, the dry Irish goodbye. I like the humor of the.
We'll give the cheers to that.
Cheers to that.
Welcome, Mark, and
Welcome, Mark.
cheers. Thank you for your contributions.
That's great, by the way.
I like that. little coffee aftertaste.
That's right up my alley.
Yes, I like.
Yeah, that
I like.
you can taste the coffee.
Yeah, the coffee, a little chocolate.
Chocolate.
Yeah.
Yes.
And very
Yeah.
smooth.
Absolutely.
No bite to that at all.
No, there's no bite to that.
All right, let's check it out.
I had a friend of mine that
It's only four.
he claimed he was a sickly child and his mother would give him stout every day.
Oh, interesting.
Yeah.
Huh.
He turns into an alcoholic, but that's okay.
He became less sickly, but he had to have a liver transplant at some point.
That's pretty damn good.
Yeah,
So
it's good.
Goes back to the
that's the best stout I've had in a while.
Yeah, it's not because I'm not a coffee drinker, and so usually sometimes stouts are just way too coffee forward. But this is not.
And this has no bite.
Yeah, the dry aspect to that, it actually makes it, you almost get no, like after
This is up your alley, right?
really.
Yeah, yeah.
Darker the better.
Pass the hazy IPA around.
All right.
You guys can take a sample of that. And you know, full disclosure, I am not an IPA fan. They generally tend to be a little hoppy for me.
Yeah, me too.
But a hazy sometimes is a little bit more smooth on the tongue. So we'll see if this is a little bit more in our wheelhouse.
You're 1 for 1 so far. You're all right.
Wonderful.
All right. And again, cheers.
Cheers. And cheers to, as you say, Jeff Campbell.
Absolutely.
Who absolutely
Okay, that's not bad.
Inside does a great job.
Yes, they do.
yeah,
Nice- nice-
It's a nice
taste
citrusy.
to it,
Yeah,
too.
absolutely.
balances out some.
Yeah, yeah.
It does, and there's really no bite to that you get.
On the
usually
nose, it's a little. It smells a little bitter. You can smell the hops in it, but you don't get that taste. It's very citrusy. It's nice. Yeah.
Yeah, that's not bad. Definitely.
I will have to tell DJ that he was right.
Man, he was right. That was
Good recommendations.
What's right percentage on that one, Conrad?
Oh, I mean, that's
That one's a little bit up there, huh?
7.3.
A little more. A little more.
And what was the stout?
It's only
4.9. Yeah. Yeah. Yeah.
That's fairly late.
Yeah, this was like those are both okay. Yeah. I would do those.
Good job, Sam. You're 2 for 2.
Uh, And glasses up to Conrad for the whole thought process of doing beer tastings during these. That's a
We can drink during work, Amari.
Well, you know,
this is why we've all been here for 20 plus years, because we work for a guy who understands us.
part of it is there's so many beers.
Oh my gosh, yeah.
I mean, I like wine as well, but and there's so many wines, but you know, beer is something I haven't explored as much.
Yeah, yeah.
You almost get intimidated when you see all these.
Agree.
That's why we give it a shot here and and just helps relax a little bit as
Yeah,
we're
yeah.
talking about all these technical.
Yep.
Great. Thank you again.
Oh no, not at all. So please have another pour of whatever you'd like if you're
It's all here.
so inclined.
Mark, we don't want you to stutter
another
too much.
pour of the
Don't have too much.
All right. Well, you can pour some.
I can top you off. Okay, no, I'm happy to help you out.
So Greg, let's talk a little about swinging away now from the fact that membrane is a lifetime and low maintenance and everything else, and let's swing into the design aspects of the Nova dryer and I guess the hopper and the feed mechanism, how that all works, because it's that hopper is quite a bit different than all dryers that you'll see in the market.
Yep. And the dual inlet aspect of this hopper.
So when you say a dual inlet, what is that?
So we're talking, you know, a traditional hopper will have some type of air inlet that will feed the desiccated air, typically towards
Most of the time it goes towards the bottom.
Yeah,
right?
exactly. So whether it enters at the bottom or has some type of swinging elbow that gets the delivery down towards the bottom section of the hopper, most hoppers will have some type of desiccated air being entered into the bottom. The Nova dryer has always been unique in the fact that we have dual inlets. So we have a desiccated inlet at the bottom, and then we have a recirculating inlet at the top. So we've always kind of referred that to our supply. So that's our supply of dry air at the bottom, and then our booster. So we're kind of in this mode of trying to boost the upper section, which in this case, we're recirculating hot air via air amplifier, a Venturi,
Right.
and pretty much using that to effectively really increase the amount of heat and air that we're pumping into the system without taxing the membrane side of it itself.
So most people would say, okay, well, I normally am used to this air in it goes down towards the bottom, and you distribute the air, and then the theory is you're drying down there, and then the air is going up through the dryer and so forth. And of course, the air is really there to carry the heat to the pellets, right?
Right.
So you add this additional one, which, another inlet, that sounds good, but Mark, doesn't that really mean that you're going to use even more energy in that case?
No, that's the beauty of this product versus other products that are out there on the market. The air that the second loop is using, it uses air amplifier measure, and basically it's an air pump. If you had a
Second loop, is it?
right, if you had a blower, you hook electric to it, and the blower turns, and the blower causes the more air to flow. But on this, we stay with the theme of this is that we don't have any moving parts, and to put a blower into here, it defeats the purpose of this product. This product that's so simple, it does no moving parts. So what we use is an air pump, a Venturi. And we use a tiny amount of compressed air to pump the air off the top of the hopper.
Return air.
The return air that's still something like -10, -15.
So it's certainly capable of drying in and of itself.
Right. So, and we bring this in to the midsection of the hopper where it's heated again and flows up.
But it's already somewhat warm.
It's already warm. So that's it. And that's the other thing is by using this air pump, we're recouping this relatively dry air, and this relatively dry air has a lot of the heat that's necessary in there already. So all we're doing is bringing that warm, relatively dry air back into the unit, and the only thing we use is this air pump.
So the compressed air coming in then is really the driver or the pump.
It causes the pump to turn,
Right.
basically, in effect.
All dryers need some utility. It's either the compressed air or they need electric or they need gas.
Right.
Right?
Exactly.
You need something to drive it. In this case, you've got compressed air, but a very small amount.
Right. So, it turns out that one volume of compressed air can pull 5 to 6 volumes of air out of the top of the hopper. They combine together, and then they are reheated. So the really another beauty of this is instead of just having it be hot at the bottom and then there's a stratification as you go toward the top, it gets cooler and cooler and cooler. This extra boost of heat in the middle of the hopper, and normally the heat's set for the same as whatever your drying temperature is.
Just to give an example, I mean, let's say you're drying nylons or something like that. I mean, the drying temperature on nylon is around 180, right?
Typically, yes.
So you're heating to 180, the air's coming in, and then maybe midway through the hopper you might be at 140,
140, 150, and at the top you might be 110, 120.
110, 120. Okay, and obviously, I guess over a long period of time you might be able to dry something at 110, 120, but you're really not going to dry the internals part of a pellet until you get it back up to 180, right?
Right. So by getting it back up to temperature very, very quickly, diffusion, which is the process most of the drying occurs by, diffusion rates are increased. So it's basically a shot of adrenaline in the system to cause the release of moisture much faster.
And you're reclaiming air that otherwise would have been exhausted.
And it would have been exhausted. And
it's exhausted.
All the competitive products out there do that. They just, they bring the air in and they exhaust it all out to atmosphere. So therefore, without this, they're using more than double the amount of compressed air to do the same job.
More than double.
More than double.
But this Nova dryer uses less than half.
Less than half.
Less than half.
About 41, 42%.
Compressed air dryers that we don't even make that type.
That's not our business, and we were lucky enough that the group that was here before I came here used the membrane that
came from a company I was associated with, and really brought dual flow, this dual flow concept, into fruition. And because they understood that compressed air is something that people want to ration. They don't.
Why do they want to ration?
Because nobody wants to go out and buy another compressor. If you don't have to do it, and you don't have to buy another compressor,
Right.
you don't have to have the power in the system, you don't have to increase your utilities in your plant.
Right.
If you can do those kinds of things, and the other things it does is it brings the economics of this product down to where normal desiccating dryers are. So when you start talking about kilowatts used per kilogram process, that's one of the key terms. It's very competitive, almost identical to what would be in a desiccating, traditional desiccant beaded or wheel type dryer for a dryer that has no moving parts.
Well, and we always believed that it was very competitive with that, but we were actually a number of years ago kind of steered into a study on that by one of our customers who's a very big fan of this dryer. They have lots of them in their plant, but they were putting in a centralized drying and conveying area for a new expansion in their plant, and we went in thinking we were going to propose a central drying system, which is what we did, and we talked about it, and they said, no, we like Nova dryers, we need those. And we said, but wait a minute, you need 20 drying hoppers here. It really makes more sense to have a desiccant central drying system. And they said, nope, we like this, it's easy, we don't have to do a lot of maintenance, our system is set up around this. And they were medical molders, so they had some certifications and so forth to deal with. And they said, why don't you go back and do a study for us and tell us how much more expensive it is for us to do this? And they weren't talking about capital investment, they were talking about operating cost, because very smart company, they knew that's the real cost, is the long term, not the initial check. We were actually very shocked. We did that study with Mark's help. Actually did a lot of measurement in their plant and here in our lab. 20 drying hoppers as opposed to 20 Nova dryers, and taking into account the cost of generating the compressed air. So what does the compressor cost per CFM? Over a 1-year time period, it was more expensive to run the Nova dryers. 20 hoppers, keep that in mind, $5,000 a year. And they looked at us and they said, why are we even having this discussion? Me hiring another maintenance guy to maintain a system would cost me 20 times that. And so we learned a lot about that just in the minimal difference in cost of operation is dramatically offset by the simplicity of the dryer, the simplicity of the maintenance, the non-demanding nature of this technology. Again, now these were small dryers, up to 20, 25, 50 pounds an hour.
That's the primary marketplace.
Exactly.
50, 25, and under.
Yeah. If we had a customer who needed a central drying system that was a bank of 200 to 600-pound hoppers, we wouldn't be having this discussion. It's completely different economics. But when we're talking about small dryers that are similar in size to what the individual Nova dryers are, it's very, very close in what the cost of operation is.
This is the closest thing to set it and forget it.
Absolutely.
As we know with many of our customers, and many of us too, we get criticized as Americans that we are a run-to-failure society.
Sure.
Okay? This thing is almost impossible to run to failure.
Okay? And that happened to me. I went in and I was talking to a customer trying to explain the different options we have for drying with Novatec, and we have a lot of drying options. We have the Twin Tower, we have the wheel dryer, we have the Nova dryer. Yep. We have a lot of options. And I was going through that, and I said how simple it is and how it really doesn't require anything other than changing the filter. And they says, come here. And they took me out into the plant, and they pushed a couple other dryers aside, and they says, is that one of those? And they said there was 2 of them in the back. They were using them every day, and all they knew is I didn't know what they were. I just know we don't have to do anything about it.
Sure.
So let's go back to the dual flow a little bit more. And talk about, I mean, the science of drying and why this dual flow in a hopper makes some sense. And then let's swing back to how this actually works with the membrane from the compressor and dividing up the airflows and how they put this all together. But let's talk about why the dual flow makes a lot of sense in this situation.
So if you look at, there's always, if you put in wet, dry air in the bottom, and as it passes up through the hopper, it's picking up moisture, and the moisture is gaining.
And it's depositing BTUs, right? As it does that.
So, but when you start looking at that stratification that occurs in dew point, they said, well, the air we're throwing away is basically the air that would exist at that point in the hopper anyway. Why can we not bring that air back in? And as it turns out, I mean, if you look at the Nova dryer, when you start looking at hopper sizes, these dry faster because everything in drying is about temperature and heat. If we can put heat in a second time, drying times comes significantly down. It's evidenced. Our 25 dryer has a 60-pound hopper on it instead of a 100-pound hopper.
Right.
Because
we go back. I mean, I know in the lab we have lots of people's dryers and we test them out all the time. And I can think of one dryer in particular where I can stick my hand in the top and the pellets are basically still cold.
Yeah, the heat never gets there.
I mean, there's no drying going on there.
To a point where it's almost a vacuum coming out of the top instead of a pressure.
When you're on the suction, when you're on the suction side of the blower that's recirculating the air, you are at a vacuum. So even the most efficient dryers, once you reach the top of the hopper, you're at a slight negative pressure because you're on the suction.
Or your side.
You're on the side of the blower.
Sure, yeah.
And then you need to provide motive force to get through all those pellets. And you use that power to get up to the top, and then you hit the suction side of the blower, and so the top of the hopper is in a vacuum. So if I can have more dense air, more hot air, and dry air throughout the entire hopper, I'm going to dry faster. It's just
The whole purpose of that. I mean, what we're trying to do really is to prep those pellets. You're trying to get them to a reasonable temperature, okay? So they're prepped to go down to the bottom of the hopper where they're finished off and powered.
right. So, but actually, probably 2/3 to 3/4 of the moisture in that pellet is removed in that upper section of the hopper with relatively dry air.
The right temperature.
But you need a polishing step.
Right.
And the polishing step is when you get down to the bottom of the hopper, you got -40 to -60, sometimes even lower, dew points that are doing and getting those pellets completely dry. And that heat now is, and you also worry about in the rheology of the pellet, having it uniform temperature throughout the pellet. So that, as you said, when you got those cool pellets at the top, that's not getting that heat into the center of the pellet. When you can get that heat all the way and give it time enough for that heat to penetrate.
Well, and that's the third component. Yeah.
Right. Exposure.
Yeah.
Soak
The time.
The
Exactly.
time of exposure.
You said
that
soak
heat.
time. So explain the soak time a little bit, Greg.
No. That's exactly the big thing is the fact that we're starting that piece of heating it up and exposing it earlier in that. Plus, we look at all this stuff in a pretty detailed scientific way to, what is the velocity going through there? How quickly is that warm air moving through the hopper so that everybody knows how much exposure time we have of trying to transfer heat into the pellet? Because that's really the key that we're trying to do there is trying to get heat into it. So we look at all that to try to make sure that we have a good, what we would consider, in the vernacular, soak time, right? So that by having that second inlet, we're starting that process much earlier and in greater volume without taxing the bottom section of the membrane while still protecting it by only having it be a single pass. I mean, that is the magic behind all that.
Keep it warm under a dry atmosphere for a long period of time. The heat penetrates all the way to the center of the pellet, You get uniformity in drying,
Let's-
and
let's-
you get uniformity in temperature.
Let's go back and drill on the uniformity issue, because I know many single flows designs, and we measure this. And Greg, you can talk about some of the profiles we look at, the airflow distribution through that hopper of how it's channeling up. Oftentimes, there's one side of the hopper that gets preferential flow of that air, and the other side's really not getting good air distribution, which means you're going to have not totally uniform
Gradient difference,
drying
right? Yeah.
going on.
Right, top to bottom and side to side.
Right.
And that's part of why we try to make sure that we have a decent pressure in the hopper too. When Mark was talking about the fact of having pressure versus vacuum within that, the good part is when we test our hoppers, our point of changing from a positive to a negative is pretty much at the outlet all the time. I mean, that is significant to the extent that we're expanding everything through the course of the entire hopper as it's moving up. Whereas we've seen in other competitive pieces where they'll start a vacuum halfway up the hopper, which as soon as you start to pull a vacuum, it's going to channel that air much quicker and try to pull it through the rest of it.
You're just evacuating air at that
Yeah,
point.
exactly. It's not trying to do anything to expand that volume. It's just trying to pull the air out.
It has to be done by, it's classic. I mean, sometimes it's different pipe sizes, the diffusers, absolute things like that.
A lot of fluid dynamics, yeah.
That's all stuff that we stress over. I mean,
Oh, yeah.
sure. We got computer programs and model these things. I mean, airflow within that hopper and getting proper distribution across the entire body of that hopper is essential to drying. Otherwise, you're going to go take final measurements at the bottom of the hopper if you want to see what your ppm is or your parts per million. You're going to find you take one reading, 5 minutes later you come back, take another reading because you're not getting uniform distribution and uniform drying.
Well, in that uniformity, the whole magic of the dual flow, which is the whole point of the discussion, is you're putting more volume of air and BTUs in two places.
Right.
And so you can't help but have a more uniform distribution,
right?
Which is just going to all kinds of positives
when you
come
look
from
at
that.
the thermodynamics of it, heat transfer is a function of mass rate and temperature difference.
Mm-hmm.
For those two things. Well, if you have thin air, if you're under a vacuum, that mass rate goes down.
Right.
So when you're talking about things that are near atmospheric pressure, these systems operate at near atmospheric pressure. A few ounces of pressure difference makes a tremendous difference in your mass that is available to carry heat. So putting heat into two spots, having the air be dense, those are the two things that affect heat transfer. You got two things, and we're handling both of those things in this dryer.
And that's why when you see something in a vacuum, it tends to pull heat out. Whereas like when you see the exhaust side of a blower, it's warmed up because you've expanded it, right? So that's why you want to pay attention to your pressure versus your vacuum side of stuff as well.
For the viewers of the podcast, you real time saw Mark and Greg go right over my head at that point.
Yeah, I think about, from a simple point of view, you're in a room. Okay, this room is relatively small, but in a bigger room, and you have your HVAC system. You have, let's say in that big room, you have one heat duct in there, one airflow coming in, and if it was on my side, then poor Tim's going to freeze his butt off, right? Okay, but if you have dual, it stands to reason. This is just, to me, it's just common sense.
If you had two
Volume,
heat
yeah.
distribution
Right.
systems on either side of the room,
Right, so
the room is going to heat a whole lot quicker.
And it's not just volume, but it's what's the word I'm looking for? It's
Uniformity.
Uniformity. Thank you.
And it's
Yeah.
distribution. So, I mean, we've done this exact simulation, right, in the software programs that we use now, where we take the amount of CFM that we know that we need for a specific Nova dryer, and we'll pump 100% of that CFM into a bottom and just let it go through a single inlet. And then we'll take the same amount and split it into two airflows, the way that we do exactly in the Nova dryer. And what you'll see is this separation that the dual flow is, and I forget what the percentage is, more effective and which means it's drying that much faster because of the way the air distribution is. I mean, distribution is a key mechanism. That's why we stress over air diffuser designs and everything else that goes into all of our drying equipment.
And when you get into the machine, the injection molding machine or the extruder, the rheology, it's how the pellet reacts at melt. The uniformity of the moisture and temperature throughout the pellet affects the part quality.
And we had this conversation 15 years ago with one of the major packaging manufacturers came here, and you all remember probably one of the best discussions we had about these kinds of things, because very informed people from that company were here. And that was one of the main points they made, which is everybody tells me how dry they're getting the outside of my pellet. Nobody can tell me how dry they're getting the inside of it.
And this goes back 25 years, because Mark, if you remember in the old days, there was somebody that was doing lenses that could only get the right clarity by using the NuvaDry.
Oh, yeah.
When you're talking about doing acrylics or polycarbonate type lenses, it's amazing difference in clarity that you see when you got the rheology of the pellet correct.
Yeah, and it's, I think that's what's driving, obviously some of the refresh in a lot of the thinking on some of these products. The dual flow on the NovaDryer. We knew it made sense. You knew it made sense when you all put that together, well before I was ever here. But now we're understanding more of the science of why that makes sense, and it's driving us to some additional things, not just in the NovaDryer, but in a lot of other areas in drying and conveying and so forth. And I know we're going to do a whole different podcast on that science and the engineering behind that. But we touched just briefly on some of this. Yeah,
but I think it's important for
this
to understand that conveying and drying are the two things that we do.
Absolutely.
And from this, you can tell we stress about this. We stress about the minutia of the details. We stress about the incoming airflow. We stress about the pipe size. We stress about the fuses. We have a more than a six-figure software program in which we model those diffusers. We model that airflow because we're trying to achieve the perfection in that airflow distribution, which then transfers the heat effectively so that you get uniform drying. And
we appreciate the tools. We really do.
No, the tools are absolutely amazing. And then further, for those people that do come out to our lab, we have 5 or 6 competitive models. We earnestly look at competitive models.
Absolutely.
We don't publish that stuff, but they're here to look at, and you can see the differences. And the differences are the subtleties of drying.
Right.
And it's in this uniform air distribution and understanding that you can't just blow hot air in there into any size hopper, and people keep putting larger and larger hoppers on in some cases.
Sure.
With the expectation that somehow, magically, this is going to dry properly. Okay? And it's almost, in his 50 years, the black magic of drying, no black magic, there's a science to it. And that science exists at Novatec. That's what we do.
Well, and I think to your point, I mean, we own our competitors' dryers, and not 20-year-old ones. No. Current models, correct. And we do that because I think I speak for all of us. We have a healthy respect for our competitors. The people who make garbage equipment are long gone. Nobody makes garbage anymore. So the difference is in the subtleties. The difference is in understanding the science. And so you can't understand that if you don't understand what everybody is doing and how to be better.
Dryer, you've got a hopper and you've got this dry air generator.
Yeah.
Okay? And everyone makes a dry air generator, but the subtleties of connecting those two together,
absolutely,
and making sure you get dried pellets out bottom is an art.
Yep.
Okay.
Yep.
But more importantly, as I said, we're turning into a science.
That's the key, I think. I agree with you 100%.
All the physics,
Yeah.
principles of physics
It is.
and heat transfer.
Yeah.
Well, I think the key out of all that really is just the fact that there's a trade-off to everything, right?
Sure.
I mean, you can pump more air or more BTUs, or you can make your drying hopper bigger or smaller, or you can do all these different things that has an effect on the process. The key is we're trying to make something that has the maximum effectiveness for drying, right? So we're trying to make something that checks all the boxes, just not some of them, that we can then provide at a cost-effective rate.
And you really have to do that, because your balanced energy, as you say, is really important. But then you have these range of polymers. You've got ABS and polycarbonate that are relatively simple to dry. And I would say most people are over drying them in many cases. Sure. Okay. But then you go to nylons, which is, they're like a sponge, right, Mark? They absorb most anything.
They can hold 10 times the amount of moisture as some other polymers.
And we have some customers who take really good care of their nylons and cover it all, the gaylords and everything else. And we have other people that it's wide open to atmosphere, and we've seen moisture levels.
And you try not to fail any of them.
Right.
Sure.
No, you have to make a dryer that works for all those regular resins, because most of our, especially custom molders, they don't know what the next job's going to be.
Well, but it's about making the dryer smart enough to recognize those differences too, because you know the traditional approach has been, build it for X hours, 4 hours, 5 hours, 6 hours, 7 hours. Right. Build it for the worst case, and the guy who has the best case will just pay the penalty. Right. They pay for more energy, they pay for more time, because we have to go to the worst case. And I think where we're striving to is to go to the real case, to what your circumstance is, and because it changes, as we all know. The same plant with the same material will have a different set of processing parameters in July as opposed to January.
Absolutely.
And so it's
next.
Yeah, and it's not a right or a wrong. It's just the reality of the manufacturing environment. And I think that's our objective, is to make the equipment smarter and more adaptable to that circumstance.
Some of the things we'll be talking about in the future.
Exactly.
But you have to start with a dryer that has that capability.
Yeah, and has good bones, so to speak.
Good bones, and has that uniformity in their distribution. Yep. That's what it all starts with. Then you can do lots of other things.
Exactly. Yep.
So with that, Mark, let's just go back and remind our viewers of those things we really tried to impart today. First of all, on this maintenance aspect, really low maintenance. Okay, lifetime on the desiccant cartridge membrane. Change some filters out, 3 filters, I think.
3 filters once a year.
Once a year, okay. But that just drilled back a little bit of how much less compressed air is used here than what the so-called
it all comes down to that dual flow arrangement and the recouping of air that any other things would just be expelled. Right. When you get down to, you're using 42% of the compressed air because of that. So I can put 2 dryers in.
You can put 2 dryers, 2.5 dryers, actually, right?
2.5 dryers in, and to equal the compressed air that one of a competitive unit would use.
You'll get better drying.
And more uniform pellet moisture, uniform temperature going into the machine.
So low compressed air usage as well. And then finally, you have this great dual flow, so that is virtually guaranteeing dry polymer at the end of the run.
And a consistent rheology at the machine.
All right. Mm-hmm. So that's an amazing combination.
It's a nice product.
And I guess the final thing in terms of updating this is we've added a touch screen this last year, right? And so
true PLC control with communication and all the things that entails. Yeah.
And so lots of our customers,
we have the ability of doing the dry convey package, so we can take it from the gaylord to the drying hopper, from the drying hopper to the machine, 7-day timer, recipe based, trending, all trending data, all in the standard piece of
And
equipment,
communications.
No extra.
Sure. So can communicate
communication,
with SCADA packages and all this.
and communicate with just about any type of system.
And we don't charge extra for the 7-day timer. It's built in there.
So,
I mean, it's just part of the package.
and the market sets the
So a
price.
7-day timer, just explain quickly what that does.
You don't have to. Well, one of the really big bonuses is I don't have to have somebody come in at 4 o'clock in the morning on a Monday morning and start my dryer up. You tell it to start up. By the time your employees start arriving, 6, 7, 8 o'clock, all they're doing is turning on the injection machine or the extruder, but they already got dry pellets ready to go.
It's just like setting your schedule on your thermostat at home. Right. So if you have 7 days and you say, well, cut it back every night at 10 o'clock to, 66 degrees, then that's what it'll do. Same thing, you can turn your dryer on and one.
Right. So all that's included. The touchscreen PLC is included, standard down, and 7-inch screen, as I recall.
This is every major request that we've had in the last 25 years that consistently would come up, that we were able to package everything together into one standard unit.
And they can pull out trending information and
Absolutely.
like that
Yeah.
as well.
I mean, it's-
Which may
And you can put a USB in it, and if you wanted to take all the recipes from one unit over to the next, instead of trying to program the next unit, you can just take a USB and transfer all your recipes from one unit. You buy a new unit, transfer all the recipes.
got it into the modern day look of every other Novatec dryer, so that you have that same look and feel, so that operator training and knowledge base and all that is much more like any other dryer that we would offer.
Well, and the main thing as well is it fits into the application theory and thought process. When we do systems, one of the things that we always try and make sure we're thinking through is how are these machines going to communicate with each other. Industry 4.0 is a big need in the market. Machine communication, machine intelligence. The Nova dryer always seemed to get left out of that. We would integrate it into systems, but it can never really talk with everything else because it just didn't have that technology. Now that's no longer the case. Now it can talk to the other dryers. It can talk to our central conveying control. You can see it from your tablets. We can do all the things that we can do with our other
You can
equipment.
go straight to your server. as well,
Exactly.
and you
Yeah.
look at all that and for your trending
If you
information.
have a SCADA system,
Yeah.
just take all the data into it.
Right. It's no longer an exception. It's got the technology that everything else has.
We have a really historic invention here that we've sold thousands and thousands of it, still highly relevant today. It's the only dual flow that I'm aware of in its class. It's the most energy saving compressed air dryer that's ever been done. It's out in the marketplace and low maintenance. I mean,
It's
Well, there are
people
variations
forget
as
they
well.
have them. It's that good.
which is wonderful.
Conrad, you and I sit and review warranties every week, and I can tell you without a doubt, this is the lowest warranty piece of equipment that we make, bar none.
Yes, I mean, as a good reminder, because we have an extensive warranty, more so than most manufacturers have. 5 years on most products, and most people do 1 year, and we obsess over that. And it's not just gratuitous and give our folks a 5-year warranty. We don't want it to fail. So truly, every week, from an executive point of view, we sit down and look at every service transaction in terms of a warranty claim, what went wrong, so we can improve the product.
Well, and Greg's charge and philosophy, and it goes, that drives all the way back to the design process. We designed to be able to offer that, because if we didn't, it would be a disaster.
100%. And I think that's really the key. And I wanted to make sure that got pointed out is we review that not to be like, what did we spend? We review it to figure out how we improve. And I just think that philosophy difference
Absolutely.
is just something that is core to us as a company.
This is a product that we never have to send in a serviceman for.
I couldn't tell you the last time we sent somebody in for something.
Right.
It's easy to set up, easy to understand, and it makes it really easy to dry, and it just keeps on ticking.
Yeah, we love it.
We do love it.
Yep.
And with that, I want to thank everybody for tuning in today,
Absolutely.
and appreciate all your time and hopefully you can tolerate our beer sampling in the midst of all that, and hopefully after hours you'll do some of the same.
Yeah.
And also, Mark, I wanted to thank you again to stay today. I mean,
Very welcome.
Dr. Drying, and truly, you are, and you've done a great job for Novatec, and I really appreciate, and I appreciate your helping us innovate on the science.
Being part of a company that supports the product and the technology, it's refreshing. It's very refreshing.
All right, folks. Well, you have a great day. Don't forget, there's other videos on the Nova Dryer. If you want to see more of Dr. Haynie, he's right there, and he'll be telling you all about the new Nova Dryer, and you get into the whole premise of the machine, as well as seeing the views of the machine itself.
Sure.
Check out YouTube. I'm sure you'll see some flash screens up on the back behind us here about where you can go for more information on the Nova Dryer. And if you have any questions directly, go to our contact page on drying, and there's a talk to the experts, and you'll see Mark's picture, and just direct your questions to him. Mark will give you a call or email you, whatever you want, and you get that piece of advice.
We'll definitely call. He likes to talk.
Yes, as you can tell, Mark likes to talk, okay? And he's a wealth of knowledge, and it's there for your usage.
Yep.
Tim, you want to wrap this up?
No, just again, I think you've said it and wrapped it up very well. Appreciate Mark and Greg and all of the technical input and information. By all means, please pick up the phone, call us, send us an email. We're happy to hear from our customers, our potential customers, or anybody who might have questions about drying, conveying, or blending, or anything we might be able to help you with. We're always here, and that's what we do for a living.
Thanks again.
Thank you.
Thank you.